Hello everyone, my name is Mark Florence and I'm with the Southwest Technical College and Solar PV Outlaws. In this video we're going to cover DC to DC converter circuits as found in the 2017 National Electrical Code. Let's get started. So continuing on talking about the maximum voltage requirements related to the converters and then coupling that with the inverter, what we have here is a spec sheet from SolarEdge for their HD wave inverters. And one thing I put right here is I said, note that the inverter will adjust each power optimizer's output and not exceed the maximum voltage requirement. So in a previous slide, what I did is we took a look at the spec sheet on the optimizers, and it didn't matter which optimizer we used, the maximum rating of those connected in series is 1,000 volts. Now we're not going to get up to 1,000 volts when we're connecting to a SolarEdge inverter, because the inverter is going to actually control and adjust the power output, both the voltage and current of those optimizers, or converters as the code calls it. The inverter will actually control and regulate that what's put out of that, so it doesn't exceed the rating of the entire system and the inverter itself. So if you take a look at this image right here, these are the, as I mentioned earlier, these are the HD wave inverters. It goes from an SE3000, roughly a 3,000 watt rated inverter, all the way clear on up to 11,400. That's roughly the rating of the inverter itself, typically on the AC side. This is the information, the input information right here. It tells you the different wattages related to the different voltages we're dealing with. So you have to match up your inverter with a specific voltage, and then tells us what the input wattage would be. The other information that we're interested right here is the maximum input voltage. You can see across the board, this applies to every single one of these inverters, is that maximum voltage you can see right there is 480 volts. So no matter, as long as in a couple of previous slides before that, it told us that some of the minimum string lengths would be 6 volt or 6 converters connected in series all the way up to 50, and if I remember right, that's basically on the three-phase 480 volt ones. Anyways, you have a wide range on those, but even if we connect 50 of those in series, we're not going to get 3,000 volts. We're not going to get 1,000 volts. Typically, what we're going to do is it'll be matched up with this the inverter, and the maximum output would be right here, 480, or whatever that inverter is. So just remember, we're combining all this information together. We're getting the information from the optimizers, or converters as the code calls it. We're getting the information off those spec sheets, coupling that with the inverter, and it determines what is the maximum output. So I would feel safe connecting up to 50 of those modules or those converters in series on a 480 volt system with a 480 volt inverter, and not exceeding the rating of any of that equipment that we're connecting to. So you're going to balance that with, whatever converter you're connecting it to and whatever inverter you're using, and you want to make sure you match all of those up and meet the minimum and maximum string lengths. Because if you on the minimum string lengths on those converters, if you connect too few, the system won't be able to turn on, and if you connect too many, you're going to exceed the rating of of the inverter. So you want to make sure you balance that. Thanks for joining me today. If you found this information to be useful and you'd either like to stay connected or be notified about future videos, please be sure to subscribe to the YouTube channel, and I hope to see you in the future. Thanks.